Hello and welcome to the Cornish Radio Amateur Club series of instructional videos for the UK Radio Amateur Examinations. I'm Rick Hall, G4 PGD, and today we're going to tackle syllabus item 2C2, which we've called potential dividers. And this is covered at foundation and intermediate levels. Starting at foundation license level, the potential divider, also known as a voltage divider, is a practical magnification of Kirchhoff's voltage law, which we examined in syllabus item 2A2. The voltages developed across multiple resistors in series around a circuit equal the source resistance. By selecting the voltages across a subset of the resistors, we can obtain a voltage that is less than the source voltage. This has many applications, including biasing transistors and FETs and providing reference voltages. Let's do a question using Kirchhoff's voltage law. Work out the value of V out in the circuit shown. Well, V out equals Vs minus V1 minus V2, which equals 6 volts. Now let's do the same question but using Ohm's law to work out the value of V out. This may be a bit hard for foundation level, more like an intermediate level question. Anyway, we first determine the current around the circuit. We need to use the total resistance, R1 plus R2 plus R3. So I equals V source divided by R1 plus R2 plus R3, which equals 12 divided by 20 and gives us 0.6 amps. This current, 0.6 amps, has to flow through R3. So we can use Ohm's law to determine the voltage across R3, which is effectively V out. VR3 equals I times R3, which equals 0.6 amps times 10 ohms, which gives the answer 6 volts. So we have solved the same potential divider problem with two approaches: Ohm's law and Kirchhoff's voltage law. This is an example of where Kirchhoff can save you a lot of time. Remember that the sum of the voltages across a number of resistors in series equals the supply voltage across those resistors. This is a learning point for foundation. Moving on to the intermediate license level. For the intermediate syllabus, the concept of using two or more resistors in series to divide a voltage is further explored. The graphic shown is such an arrangement using two resistors. The intermediate syllabus calls for us to use the formula which is provided in the exam on EX308. The graphic shows the formula and the circuit to which it refers. Let's do a question using this formula. A potential divider has V in equal to 5 volts, R1 to 20 ohms, and R2 equals 50 ohms. What is V out? Well, V out equals 5 times 50 divided by 20 plus 50, approximately equal to 3.6 volts. If you're presented with a question that has 3 resistors, you will need to combine the value of 2 resistors into a single equivalent resistance to use this formula. And this illustrates one problem with using the EX308 formula. The potential divider formula in EX308 is specific to the two resistor circuit shown in the graphic. For example, if you swap the labelling of R1 and R2 on the diagram, you will get the wrong answer for Vout. Although it adds an extra step, it's probably better to work out the current through the divider and use this to work out the voltages, as it's a more generic approach. So, rather than use the formula given in EX308, consider determining the current through the resistor chain and use that current to work out the voltages across the various resistors. Let's look at a more complicated question to see how to first work out the current and then use this to determine the output voltage. What is the value of Vout in the potential divider below? Well, firstly, we work out the total current through the resistor chain. Remember to use the total resistance RT equals R1 plus R2 plus R3 plus R4. I equals V divided by RT, which equals 12 divided by 20 times 10 to the 3, which gives our circuit current 600 times 10 to the minus 6 amps, or 600 microamps. Using this circuit current, we now work out the voltage across R3 and R4. Vout equals I times R3 plus R4, which equals 600 times 10 to the minus 6 times 7 times 10 to the 3. Now we have Vout of 4.2 volts. Let's do a slightly more complicated or difficult question where we are not given the current through the potential divider or V in. What is the value of Vout in the circuit shown below? Well, we can easily determine the current through the resistor chain because we can use Ohm's law to determine the current through R2, and Kirchhoff's current law tells us that it's the same current in the other resistors. I equals V over R2, which equals VR2 divided by R2, which is 15 volts divided by 6 kilo ohms, which gives us 2.5 milliamps. And using this circuit current, Vout equals I times R3 plus R4, which equals 2.5 milliamps times 5 kilo ohms. So Vout is 13.75 volts. Now that we have the current, it's fairly straightforward to work out V, in which it's simply the circuit current times the total resistance. So that is 2.5 milliamps times 12 kilo ohms, which works out to be 30 volts. Practice some voltage divider problems with 2 or 3 resistors so that you can work out values for V in, V out, or the resistor values as required. In the next video, 2C3, we look at potential difference, PD, and electromotive force, EMF. So that concludes syllabus item 2C2, potential dividers. Thank you for watching.